Hello guys, welcome back. This is another video where we discuss the previous year questions on network theory, and here we have a question from GATE EC 2020. So the current I in the given network is dash. Okay. So here they have given the network, and if you notice here they have mentioned it as ZZ, and here also they have mentioned it as Z, and they have given equal to 80 minus J35. So actually the Z value is given. You shouldn't think it as they have not given this. Okay. And we have two voltage sources and they're asking to find this current I. And we have four options. If you see in all the other three options, the amplitude or the magnitude is 2.38. So if we confirm that if it is not 0 ampere, we only need to find the angle of the current I. If we find the magnitude and if we see that it is 0, then we can choose option B. Okay. So with this information, let us proceed. Okay. So now in this circuit, the ground node terminal is not given. So we are free to choose whichever node we want as ground. Ground is nothing but a reference. So I'm choosing this node as my reference. Okay. Let me copy this circuit. Okay, so now this is my reference. If you see, the voltage across this is equal to this voltage. So what will be the current in this? So my I1 will be 120 angle minus 90 degree divided by Z. And similarly, what will be my I2 here? If you see the voltage across this is this voltage, right? So my I2 is 120 angle minus 30 degree by Z, right? And what is I now? I is nothing but it is minus of I1 plus I2. So minus of I1 plus I2. So if I1 was equal to minus I2, then we could have said that the magnitude is 0 ampere. But here if you see they are not related by minus 1. So the amplitude is not 0. So amplitude should be 2.38. We only need to find the angle. So now we have to add two quantities. Now they are given in polar form, right? I1 and I2 are in polar form. For addition and subtraction, it is good to perform it in rectangular coordinates or rectangular form. Similarly, for multiplication and division, it is easier to do it in polar coordinates or the polar form. So now since it is addition we are doing first, let us first convert them into rectangular form. Okay. So my I1 is nothing but 120 angle minus 90, or let me directly write I only. I is this plus 120 angle minus 30 degree divided by Z. So my Z is common. I will substitute at last. So 120 cos minus 90 plus J sin minus 90. Cos minus 90 is 0. J sin minus 90 is minus 1. So minus J plus 120 into cos minus 30 is equal to cos 30, which is root 3 by 2, plus J into sine of minus 30, which will be minus 1 by 2, right? So now this will turn out to be minus 120J plus 60 root 3 minus 60J. So together it becomes 1 by Z into 60 or minus 60 root 3 plus 180J. Okay. Now my Z is nothing but from here 80 minus J35. So minus 60 root 3 plus 180J divided by 80 minus J35, right? So now what we have to perform? We have to perform a division. So then it is easier in the polar form. So let us convert this into polar form. So this conversion again I will tell you here also. So if you have A plus JB, then to go to polar form and come back, your R angle theta, your R will be nothing but root of A square plus B square, and your theta is nothing but tan inverse of B by A. Similarly, for this is the other way, right? To go from here to here, it is just R into cos theta plus J sin theta. Okay. Okay, now we have to go the other way. So for this, what will I get? If I take the magnitude, it will be root of 60 root 3 whole square plus 180 square, which is 207.85. And my angle will be tan inverse of 180 by minus 60 root 3. So here if you see the cos theta term is negative. So if you have the four quadrants, you know that here both are positive. Cos and sine are positive. Here cos is negative, sine is positive. And here you have cos positive, sine negative. And here both your cos and sine are negative. So if you see here, your cos is negative, sine is positive. So it is in second quadrant. So now let us try to find the value. So tan inverse of 180 divided by 60 root 3. So this is 3 times and this is nothing but tan inverse of root 3. Tan inverse of root 3 is 60 degree, right? But it should be in my second quadrant. if you remember, tan theta is equal to tan of 180 minus theta. So this angle I can write it as 120 degree. So this is angle 120 degree. Similarly, for this thing, if we find the magnitude, it is root of 80 square plus 35 square, which is 87.32. And my angle is tan inverse of, here if you see the sine theta is negative, so it is in the fourth quadrant. So tan inverse of 35 by 80, which is nothing but 23.63 degrees. So this, since it is in fourth quadrant, I can write it directly as minus 23.63 degree. So if we calculate this, anyway, we know that our magnitude we are not concerned, only the angle we are concerned, right? So if you want to cross check, I am also calculating the magnitude. So 207.85 divided by 87.32. So this is 2.38, and my angle is this plus this, since it is in division. So it is 143.63 degrees. So this is my answer. If you see here, it is option D.